be looking at ionic equations. Okay, so the learning objective is to write ionic equation with state symbols. So previously, I have briefly introduced the difference between different types of equations, like word equation, chemical equation, and also ionic equation. So far, you have already done all the different word equation and also chemical equation practice, including how to balance. So what is an ionic equation? An ionic equation is a simplified version that shows only the ions that react in an aqueous solution. So in this, spectators ions, okay, they are actually ions that do not take part in a chemical reaction. So in an ionic equation, we remove spectators ions. So briefly, this is how you write an ionic equation. From a word equation, you have changed it to a balanced chemical equation. And after you have cancelled out all the spectators ions, okay, I'll go into details later on. So as you see, all the blue color ones are the spectators ions, because before the reaction and after the reaction, they remains the same. So I can cancel them out. So leaving behind all the green color ions or substances. Okay, and then this is what we call the ionic equation. Okay, so in detail, how do we write an ionic equation? Step 1. For a reaction between hydrochloric acid and sodium hydroxide, you write a balanced chemical equation including the state symbols first. In this case, there's no need to balance as all the atoms of the elements Na, H, O, and Cl are balanced on both sides. After which, you rewrite the chemical equation in terms of its ions. So HCl, which is hydrochloric acid, they are able to ionize. Although it is a covalent substance, it can be ionized into H+ and chloride ions. Okay, so for sodium hydroxide, it is an ionic compound. An ionic compound usually are able to dissolve in water. So usually soluble in water. So we can write them into sodium ions and hydroxide ions. And after reaction, sodium chloride that is formed is the same thing. It's an ionic compound that can dissolve in water. However, for water, it's a covalent substance. So it's a covalent liquid that do not ionize in water, which is itself. So after you rewrite all into its ions, this is when you cancel out the spectators ions. If you look closely, sodium hydroxide gives sodium ions. Sodium chloride gives sodium ions. So they are actually the same ions before and after the reactions. Same for the chlorides. So we cancel this out. You will see that you have the H+ or H- that is taking part in the reaction to form water. So in an ionic equation, if you are told to write with the state symbols, you have to include all the state symbols. Otherwise, you can leave them out. So this is a guideline of some of the substances that do not ionize in water. What does do not ionize means? do not form ions. So do not form ions in water. So insoluble solids, this includes ionic compounds. Some of the examples are the insoluble salts like silver chloride. You will learn about solubility of salt later on in later chapter. Okay, metals are also insoluble solids. Covalent liquids such as water, you write as H2O in liquid form. Gases, example carbon dioxide, leave it in gaseous state. So liquid and gas state, you do not write in ions. Selected solid, selected AQ like chlorine, you also do not write as ions. Okay, because they are covalent substances. And they have very strong covalent bonds. Okay, so do not break them into its ions when you write the ionic equation. So H2O remains in liquid as a full formula, and silver chloride in solid as a full formula. Okay, silver chloride is actually this. Okay, so moving on. Another example I'll give you is reaction of sodium chloride with silver nitrate solution. Okay, I have completed the question a little bit more to include the state symbols of all the products since you have not learned in detail. So precipitate means it is solid. Solution means it's AQ. So reaction of all these solutions are all AQ. So you write balance equation first. So this is sodium chloride. This is silver nitrate. This is silver chloride, which is a precipitate, and this is sodium nitrate. Okay, so rewrite them into its ions. So all the AQ ones, because they are ionic compounds, you can form into its respective ion. Okay, it's actually the backwards of doing the formula. So when you do the formula, silver nitrate, for example, okay, this is the formula. You break it back into its ions, you are doing a backwards. Okay, so after that, you cancel out the spectators. So you can see that Na plus, okay, they are repeated in the reactants and products. Okay, you can tell also that silver, no, not silver, nitrate. Okay. Oh, sorry, this one is cancelled wrongly. So this should be cancelled away. This one should be remains there. Okay, because there is no silver chloride solid in the reactants. So after you cancel all the spectators, okay, you will be left with all the ones that take part in the reaction. So we can read this as chloride ions and silver ions form the precipitate. Okay, this is called an ionic precipitation reaction. So in an experiment, how can this be seen? Okay, you have here a lot on precipitation already. So precipitation is actually a solid over here that is formed in a solution. So silver nitrate, for the example that was given just now, reacts with sodium chloride. That means you just mix them together. They are both colorless solution. After you add them together, you see a precipitate that forms. Okay, this is the white solid. There is also a colorless solution, which is the solution that contains the sodium ions and nitrate ions that remains unchanged during the reaction. So those, we call them the spectators. So let's run through the steps. Just now, the first part is to write the chemical equation. Then, to write the chemical formula of all the ions. And then cancel out all the spectators. And there you have an ionic equation. So this is how chemical equation is related to ionic equation. Okay, there are further examples in your resource package. So on this 7.2 chemical resource package, please pause the video here to take a look and fill out your resource package on what is ionic equation. Okay. Then let's look at example 1. Solid calcium carbonate. So solid calcium carbonate, this one, reacts with dilute hydrochloric acid to form a calcium chloride solution, okay, and water and carbon dioxide. So for this, we can write into aqueous ions for this. And aqueous calcium chloride, the ions are these. So be very careful. Calcium chloride means there is calcium 2 plus ions and 2 Cl minus ion. 2 HCl means there's 2 H plus and 2 Cl minus ions. Okay, the rest, water, carbon dioxide, and calcium carbonate, they are solid, liquid, and gas. They do not change to its ions. Okay, even for calcium carbonate, it is a ionic compound, but because it's a solid that do not dissolve in water. So you cancel out the chloride ions because they are repeated in the reactants and products. And you are left with the spectators ions. Okay, pause a while in here and copy down in your notes. Okay, in the next example, when sodium sulfate solution, okay, so it's a solution, write out the formula, and then barium nitrate solution, write out the formula. They form a white precipitate. So precipitate means it's a solid barium sulfate. And your last one is a sodium nitrate solution. So only for those that are aqueous, they can be dissolved. Okay, there's an error here. There should be Na plus. Okay, so this came from this substance. This is AQ still. So from here, okay, be careful of brackets like that. So what it means is there is 2 sets of nitrate ions. Okay, then for solid, no change. And this one, change between its ions. Then you cancel out. Okay, so there's something missing here. Na plus, they are exact ions, cancel out. nitrate ions, they are Z, and then you get the overall ionic equation. If state symbols is needed, write at the side. Okay, otherwise you can write the ionic equation without state symbols. Pause the video here to copy down in your resource package. Okay, so on the next page, there are 3 questions that you can try out. Pause first and try it out before looking at the final answer. Okay, so there's some errors here. And it's not clear. Okay. After you have tried out, you can write this, check your answers, and write this into your chemistry resource package. And for offline work, complete assignment 7, page 93 to 94. Okay, MCQ 7 to 10. These are all the ionic questions. Ionic equation questions, page 95 to 96, part 2 of question 2. So for example, you are given 2A part 1 already. So from your answers, do all the part 2. Okay, as this video is made for 2 different groups of students, if you are in Group A, 3A Science Chem 1, 2, or 3, because your lesson is on the 22nd April, please submit at 6 p.m. If you are in Group B, whether my group or Miss Sim's group, please submit this by 6 p.m. on the day you are assigned this lesson. Okay, thank you.